ASDIP includes the design of continuous beams of different materials such as concrete, steel, and wood. However, sometimes it's necessary to model and design a single cantilever beam. This is Javier Encinas, and today I'm going to show you how to model and complete the design of a single cantilever beam using ASDIP software. For illustration purposes, the following example corresponds to a concrete beam designed using ASDIP Concrete, but this feature is present also in ASDIP Steel and ASDIP Wood. Let's get started. As an example, let's consider this 6 feet long concrete cantilever beam. For illustration purposes, let's assume that it's supported by a concrete column in a building, which provides a full restraint support. The cantilever beam supports uniform and concentrated loads as shown here. The uniform loads are 300 PLF dead and 600 PLF live. In addition, a concentrated load at the end of the cantilever span is 1 kip. The dimensions of the beam section is the width 12 inches and the height 16 inches. The goal is to design the reinforcement of this beam. To do that, let's go to ASDIP Concrete. When you open ASDIP Concrete, you see the project manager. Here you can see the modules included in the package: concrete columns, concrete beams, concrete or masonry bearing walls, one-way slabs, and concrete shear walls. In this case, we're going to design a concrete beam. I have already prepared an example. Just click on this node in the tree. And this is the template of the beam design module in ASDIP Concrete. Here at the left, we enter the geometry. The beam type is rectangular, and we know that the width is 12 inches and the height is 16 inches. Since this is a cantilever beam, the number of supports is just 1. This is a new feature in ASDIP Concrete. It's also present in ASDIP Steel and in ASDIP Wood. Now you can select one support from this combo box. And the program shows the cantilever span. In this case is 6 feet. Also, the program shows automatically that is only one support and is fixed. So this is the geometry condition for our example. Let's go to the Materials tab. Here we specify the material properties, concrete F'C 4 and density 150 PCF. Let's go to the Loads tab. Here we enter the information given in the statement of the problem. The uniform load applied to this beam, in addition to the cell weight, depth 100 PSF multiplied by a tributary width of 3 feet would be 300 PLF, and live load 200 PSF affected by a tributary width of 3 would be 600 PLF. In addition, if we go to the Concentrated tab, here we enter the concentrated load. It's at the end of the span, so it's at 6 feet from the support, and live load of 1 kip. Graphically, this is the beam that we just modeled, which is 6 feet long, and is affected by a uniform load and a concentrated load as shown here. Please note that the program generates the shear diagram and the moment diagram for this beam, and also the program shows the controlling load combination. Here at the bottom, you can see that the maximum moment is 37.7 kip feet and the maximum shear is 9.1 kip. If we go to the At a Glance tab, we can see all these numbers here just in one screen. The maximum MU is 37.7 at the support. The maximum shear is 9.1. Before we go to the capacity ratios, let's go to the Reinforcement tab. Here I have entered already some rebars for this beam. At the top bars, I specified 2 number 5s continuously at the top, and at the bottom, the same 2 number 5s. So specifying 2 number 5s top and bottom. If we go to the stirrups, we are specifying 12 stirrups number 3 at 6 inches spacing. Let's see if we can optimize this design. Here at the At a Glance tab, we can see that the ratio for bending is 0.97, which very well optimized. We can increase the capacity a little bit if we want to reduce this ratio. For example, if we go to the top bars, here we can add one rebar number 5, 3 feet long, just at the left end. And now the ratio is 0.67. In shear is very comfortable. The ratio is 0.23 with the stirrups. We can see here at the bottom that all the ratios are passing. So the reinforcement is complying with the code provisions. We can probably increase the spacing of the stirrups. Instead of 6, let's say 7. And we still comply with the code. Everything is passing. And the ratio increased a little bit. So it's a little bit more optimized. We don't have torsion in this example. If we go to the Condensed tab, the program shows a more detailed set of calculations grouped by topic. Here are the support reactions, the shears for the different load combinations. Every combination is passing because compares versus the shear strength. Here, everything passes. These are the bending moments at the support for each load combination. And everything is passing if it compares to the bending strength calculated here. Also, the program calculates the deflections. In this case, are very minimum deflections here. It's a short beam. And finally, the program shows the load combinations used in this example. If we go to the Detail tab, we can see a more detailed set of calculations, step by step, with exposed formulas and references to the ACI code. Graphically, these are the shear and moment diagrams discussed before. If we are interested in see the capacity of this beam, we click on this checkbox. The green is the contribution of the concrete itself. Blue is the contribution of the steel. The same for the bending. If we click on this checkbox, this is the capacity of the beam, the blue area. As you can see, it's very easy to design single isolated cantilever beams using ASDIP. In this example, we use ASDIP Concrete for illustration purposes, but this feature is also available in ASDIP Steel and ASDIP Wood. If you like the software, please visit the website www.asdipsoft.com and download the free 15-day trial. Please subscribe to the channel if you want to receive notifications in the future for similar videos. Thank you for your attention.